Let's solve more questions from Similarity. Now, these are questions specific to maps and models. The first question is that on a map drawn to scale of 1 is to 50,000, a rectangular plot of land ABCD has the following dimensions: AB is 6 centimeter, BC is 8 centimeter, and all the angles are right angles. We need to find the actual length of the diagonal distance AC of the plot in kilometer and the actual area of the plot in square kilometer. Now, to answer this question, we need to first understand unit conversions, because here they have specified that the answers must be in another unit. So that, and also the concept of scale factor. Now, the rectangular plot of land, the actual plot of land, and what is represented on the map, they are similar figures. So, their dimensions will be in the same proportion, but of course, the sizes are different. So, let's say that the map, the rectangle ABCD, has some dimensions ABCD. This is the map, the representation of the rectangular plot on the map, and AB is 6 centimeter, BC is 8 centimeter. We would need to find the diagonal AC. But let's say the actual rectangular plot will have different dimensions. Let's say A dash, B dash, C dash, D dash. This is my actual rectangular plot. Its dimensions we need to find in kilometer, specifically the diagonal AC. So the scale factor of 1 is to 50,000 is given. I will use that. But let's also now revise the unit conversion. Dimensions are given in centimeter. We would need to convert to kilometer. So let's look at how that can be done. If you remember, we know 100 centimeter is 1 meter. So 1 centimeter is 1 by 100 meter. So if I have any length in centimeter, just multiply with 1 by 100, which is same as dividing by 100 to get the equivalent meter. Also, we know 1000 meter is 1 kilometer. So 1 meter is 1 by 1000 kilometer. So whatever value we have in meter, we just need to multiply with 1 by 1000, which is same as dividing by 1000 to get the equivalent kilometer. So if I started with 1 centimeter, that is same as 1 by 100 meter, and have to further divide with 1000 to get its equivalent in kilometer. That's how we can do the conversion. So let's look at the first part now. The actual length of the diagonal distance AC in kilometer. We will first find the distance AC in the map. So if I look at the map, ABCD is a rectangle, so angle B is 90 degree. If I apply Pythagoras theorem, AC diagonal will be 10 centimeter. 6, 8, 10 is a Pythagorean triplet. Now let me apply the scale factor, the knowledge of scale factor. So scale factor is the length in map over the actual length, and that is given as 1 by 50,000. So let's say the diagonal AC, the length in map AC, and the actual length A dash C dash, the ratio is 1 is to 50,000. So that means, let's say the length AC in the map is 10 centimeter. So 10 centimeter over A dash C dash is 1 by 50,000. So that means A dash C dash is actually 50,000 into 10 these many centimeter. Now if I want to convert to kilometer, if you want, you can do it step by step. So centimeter to meter, I need to divide with 100. So this is 50,000 into 10 whole divided by 100. These many meters. Now meter to kilometer, I need to divide with 1000. So 50,000 into 10 by 100, and again divide with 1,000. So the meter will now become kilometer. Now here we will simplify the fraction by removing the zeros. So let's say we have 3 zeros here, 3 zeros gone, then 2 zeros, 2 zeros gone. So only 5 remains. So the actual diagonal AC in the rectangular plot is 5 kilometers. That's the answer to the first part. Then for the second part, they're asking us what is the actual area of the plot in square kilometer. If I look at the map, the length and breadth are 6 centimeter and 8 centimeter. So the area in the map is 6 into 8, which is 48 centimeters square. Now we need to find the area of the plot in square kilometer. So let's first understand the conversion of square centimeter to square kilometer. So let's say I had 100 centimeter is 1 meter, and also the fact that 1000 meter is 1 kilometer. So that means 1 centimeter is 1 by 100 meter, and if I further divide this with 1000, I will get the equivalent kilometer. So 1 by 100 into 1000. So 1 centimeter is same as these many kilometer. And if I want to find in terms of area, I would need to take the square on both the sides. So that will involve a lot of zeros. So if you want, we can write in terms of exponents. So 1 centimeter square area is same as, so I said exponent. So this is 1, 2, 3, 4, 5. This is 10 to the power 5. So it is same as 1 by 10 to the power 5 whole square. And according to laws of exponents, this will be 1 by 10 to the power 10 kilometers square. So 1 centimeter square is 10 to the power minus 10 kilometers square, or 1 by 10 to the power 10. So then I will say that area of the map, the rectangular plot in the map, is 6 centimeter into 8 centimeter, which is 48 centimeters square. So therefore another thing about the ratio of areas when we are looking at the map and the actual area, it will be equal to the square of the scale factor. So area of map by the actual area is actually square of the scale factor. The scale factor itself was 1 by 50,000, so it will be the square of that. Okay, so it is kind of a bit calculation, but if we do it smartly, it will not be very tedious. So area of the map is 48 centimeters square divided by actual area. This is equal to 1 by 50,000 square. So then the actual area is equal to, if I cross multiply, 50,000 square times 48 centimeter square. But I don't want centimeter square, I want kilometer square. So I just need to do, so whatever value we have in centimeter square, if I divide with 10 to the power 10, I will get its equivalent in kilometer square. So this thing divided by 10 to the power 10 will give me in kilometer square. So if I patiently write down, so 50,000 square is 50,000 multiplied by 50,000, and now dividing with 10 to the power 10. So you have to count 10 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the value in kilometers square. Now just patiently cross out the zeros. There are 4 zeros here. Cross out 4 zeros. Then 4 more zeros here. You will cross out 4 zeros here. So then we have 5 into 5 into 48 by 100. So if you do the calculation, we will have let's say 5, and this is 20, this is 1, this is 4, and 48 by 4 is 12. So 12 square kilometer. That's the actual area of the rectangular plot. Then the last question is that the model of a building is constructed with the scale factor 1:30. If the height of the model is 80 centimeter, find the actual height of the building in meters. And if the actual volume of the tank at the top of the building is 27 meter cube, find the volume of the tank on the top of the model. Alright, so here we are talking about a model with the scale factor 1:30. So let's say the first part was talking about finding the height. Height is just a length. So the ratio of length is given as 1:30. That's the scale factor 1:30. So let's say that height of the model by the actual height is my scale factor, which is 1/30. Now height of the model is given as 80 centimeter. So 80 centimeter by actual height is 1/30. So therefore my actual height, if I cross multiply, is 80 times 30 centimeter. But again they have asked me the height in meters. So if I have in centimeter, I just need to divide with 100 to get the equivalent meter. So it is 80 into 30 by 100, these many meters. So if I now cancel the zeros, 8 into 3, we have 24 meter. So that's the actual height of the building. Then they are talking about something to do with the volume. Now for actual thing and the model, the ratio of the volumes will be the cube of the square factor. So I will say that the volume of model by the actual volume is actually the cube of the scale factor. Scale factor itself is given as 1/30, so it will be the cube of that. Now there was information about the actual volume at the top of the building is 27 meter cube. Now they're asking find the volume of the tank on the top of the model. Okay, so let's say volume of the, so actual volume is 27 meter cube, and let's say volume of the model is x. So this is 1/30 cube. So if I look at it like this, so this is the volume of the tank in meter cube. If I just simplify it a little bit, this is 9, this is 10, then this is so it is 1/1000 meter cube. Here I don't see the unit specified, so I can leave the answer as the volume of the tank in the top of the model is 1/1000 cubic meter, or if you want to write in decimals, it is 0.001 meter cube.